Hi, in this video, I will introduce you to uncertainties in measurement and how to report them. Right. So here you see three instruments, three measuring devices measuring whatever they are intended to measure. The first is a scale, which is measuring the length of a pencil. The second one is a speedometer, showing the speed at a particular instant. Let's assume it's in kilometers per hour. And the third is a weighing scale, showing the weight of an object. Assume it is in kilograms. Right. Now you must be knowing that any instrument has a certain minimum measurement that it can take, which is called the least count of the instrument. Let us quickly analyze what is the least count of each of these instruments. The first one is the scale, which has markings of 1 centimeter, 2 centimeter, and so on, as you can see. So the least count of the scale that you see here would be 1 centimeter. And next is the speedometer. The readings on it, as you can see, they are marked 0. Next one would be 10, 20, 30, 40, and so on. So the least count of the speedometer that you see here is 10 kilometers per hour. And the third one, the weighing scale, the markings on it, if you observe, you can see 50, 51, 52, so on, up to 60, increasing up to 70, 80, and so on. So each marking there indicates 1 kilogram. So the least count of that weighing scale is 1 kilogram. Right. Right. Let us now try to record or note down the measurements indicated by these instruments. The tip of the pencil in the first case lies between the 9 centimeter and 10 centimeter mark. So we know it's greater than 9 centimeters but less than 10. So how do we note down this measurement? Is it exactly 9 centimeters? No. Or can you say it's like 9.3, 9.4 centimeters? No, because I mean, we can guess, but according to this scale, we cannot say anything more than that. We can only say that it's somewhere between 9 centimeters and 10 centimeters. Okay. Now the least count of the scale is 1 centimeter. So when you record this length, I'm calling the length of the pencil as L. So when we record this length, you should record it as 9 centimeters. So why did I choose 9 centimeters? Because the tip of the pencil appears to be closer to the 9 centimeter mark than the 10 centimeter mark. So I'll take it as 9 centimeters. But there is some deviation as well. I mean, there is a possible, I mean, there is an uncertainty in this measurement. You're not sure that it is 9 centimeters. Okay? So we need to indicate the possible deviation in measurement as well. And the possible deviation in measurement would be the least count of the instrument. So the proper way to record or report this measurement would be L equals 9 centimeters plus or minus 1 centimeter. What it means is that L could lie anywhere between 9 minus 1 centimeters to 9 plus 1 centimeters. That is from 8 centimeters to 10 centimeters. Now it's quite clear that the tip of the pencil is between 9 and 10. So it's somewhere between 9 and 10. We can say that, but the proper scientific way to report this measurement would be to say that it is somewhere between 8 centimeters and 10 centimeters. So we write it as 9 plus or minus 1 centimeters. So you can try to record the second measurement now. The second measurement, the needle points towards 120, 130 and 140 kilometers per hour, and it's almost pointed exactly towards 140 kilometers per hour. So can you be sure that it's exactly 140 kilometers per hour? No. Even when it is pointing directly towards that marking, we cannot be sure that the measurement is actually 140 kilometers per hour, because the marking itself, as you can see, it has some thickness. The needle has some thickness. So how can you be sure that it's exactly 140.0000 kilometers per hour? We cannot. So even if the reading shown seems to be exact, we need to report it with the possible deviation. That is, we need to indicate the uncertainty in the measurement as well. So we note the speed V as 140 plus or minus the least count, 10 kilometers per hour. That is the proper way to report the measurement. Now you can try and report the third measurement. The weighing scale clearly shows 61, 62, 63, 64. The needle is covering the 64 marking. But still, as I said, the needle has some thickness, the marking has some thickness, we cannot be sure that it's exactly 64 kg. So the weight indicated by it should be noted as 64 plus or minus 1 kg. That is the proper way to report that measurement. So this is what we call as uncertainty in a measurement. There is no instrument which does not have an uncertainty in measurement. There are many other sources of uncertainty as well. Due to temperature, the scales expand, contract. So there may arise an uncertainty because of that. There are other possible sources of uncertainties or errors, like using wrong experimental technique, wrongly calibrated instruments. So there is always a possibility of an uncertainty in a measurement, and you are supposed to indicate the maximum possible deviation, the maximum extent up to which your measurement could go wrong. And this is the proper way to do it. There is also a name given to this. It's called as absolute error in the measurement. So when you write measurements like this, also indicating the possible deviation in the measurement, this value is called the true value, and the possible deviation is called the absolute error in the measurement. So in the next reading that you see, 140 kilometers per hour, that is the true value of the measurement, and 10 is the absolute error in the measurement. Similarly, 64 here is the true value, 64 kg, and 1 kg is the possible deviation, maximum possible deviation, and that is called the absolute error. So whenever you report a measurement, any measurement must be reported in this form. Let's say you are measuring this quantity called X. So you need to report it as a true value plus or minus the maximum possible deviation. This is the correct way to report any measurement followed by the unit. There are a few things that you need to note here. The absolute error in a measurement or the possible deviation will be usually kept a positive quantity. There's no point in writing a negative there after the plus or minus. So we keep it as a positive value. That's why it's called the absolute error. And one more thing you need to note is that the true value and the absolute error will be written in the same units. For example, 9 plus or minus 1 centimeters. 9 and 1 are both in centimeters. Likewise, the other quantities as well. In the next video, we will look at how to consider these possible deviations and add measurements or subtract measurements, multiply or divide them. For example, let's say one length had some uncertainty in its measurement, and let's say another length also had an uncertainty in its measurement. So we don't know any of them for sure. Then how do we report their sum or the difference or the product or the quotient? By considering these possible deviations. We will look at that in the next video. Thank you.